All right, let's talk about something we're all surrounded by but almost never think about: the invisible forces of physics. They power pretty much everything, but what's really fascinating is how they have these incredibly clever safety features built right in, hiding in plain sight. Let's go find them.
Okay, so picture this. You're in your kitchen, right? You've got a toaster, a kettle, maybe a washing machine. And they've all got these metal bodies. They're plugged into the wall, electricity's flowing, which, when you think about it, leads to a pretty important question.
I mean, it feels like it should be a recipe for disaster, doesn't it? Metal plus electricity, that just sounds dangerous. But we use them every single day without getting zapped. Why? Well, the answer is just a really clever and actually pretty simple bit of physics. And that's what we're going to break down.
So, to get to the bottom of our safety mystery, we have to back up a little and talk about a fundamental partnership in the universe. It turns out anywhere you find electricity, you get a little bonus prize: magnetism.
Yeah, they're basically two sides of the same coin. An electric current isn't just, a bunch of charge flowing. It's actually generating this invisible force field that wraps around the wire. But here's the thing, this field isn't just a random cloud, it has a specific direction. So how in the world do we figure out which way it's going? Well, physics has these awesome little tricks, kind of like secret handshakes, to help us figure this stuff out. And this is the first one we need to learn. It's a super simple way to actually see in your mind's eye the direction of this invisible magnetic force.
And check out how simple this is. All you do is imagine grabbing the wire with your right hand. Your thumb, that points in the direction the current is flowing. And the way your fingers just naturally wrap around, bam! That's the direction of the magnetic field. Seriously, it's that easy.
All right, pop quiz time. Let's try it out right now wherever you are. Point your right thumb straight up at the ceiling, like you're giving a thumbs up. Now look at how your other fingers are curling. Which way are they going?
And the answer is anti-clockwise. If you saw that, you nailed it. You just used a basic physics rule to predict the direction of an invisible force. How cool is that?
Okay, so we know a current makes its own magnetic fields. But what happens if you take that wire and stick it inside another magnetic field, like between two magnets? Well, that's when things get interesting. The two fields start to interact, and they create a real physical push or pull, a force. And you guessed it, we've got a rule for that too. So take a look at this. This is our next puzzle. We've got this wire labeled AB, and it's sitting right there in a magnetic field. We know the current is flowing, we know the field is there, but which way is the wire actually going to get pushed?
Time for our next secret handshake, Fleming's left-hand rule. Now, this one looks a little like you're making a finger gun, but trust me, it works every time. You just stretch out your thumb, your forefinger, and your middle finger so they're all at 90 degrees to each other. Your forefinger points in the direction of the field. Your center finger points for the current. And your thumb, that magically shows you the direction of the force. Okay, let's put it to the test with our diagram. The magnetic field goes from north to south, so point your forefinger down. The current is shown by that symbol, which means it's going into the screen, so point your center finger away from you. Now, without moving anything else, look at your thumb. Where's it pointing? Straight to the left. And that's our answer. That's the direction of the force.
Now, this might seem like just a neat little trick for predicting a tiny push on one little wire, but these rules are the foundation for creating really powerful, really controllable forces. By just arranging wires in clever ways, we can amplify these effects to build basically all the tech that runs our lives. And a perfect example of this is something called a solenoid. It sounds complicated, but it's not. Instead of just one straight wire, imagine taking a super long piece of insulated copper wire and just wrapping it into a tight coil, like a spring. When you run a current through that whole coil, something really cool happens with the magnetic field. So what's the big deal about this coil shape? Well, look at the magnetic field it makes. On the inside, all those little magnetic fields from each loop add up and become these perfectly straight, parallel, and really strong lines. It's like you've created a perfect magnetic tunnel. And being able to create a uniform field like that is absolutely crucial for everything from the starter in your car to the valves in your washing machine.
All right, we've talked about current, we've talked about fields, we've talked about forces. We now have all the puzzle pieces. So let's go all the way back to the beginning and solve the mystery of your metal kettle.
So, how does all this magnetism stuff connect to you not getting shocked? Well, the answer isn't in two wires, but in a third one. You know how some plugs have three prongs instead of two? That third prong is the key. It connects to the unsung hero of electrical safety.
Okay, here's the brilliant part. That third wire, we call it the earth wire, is connected directly to the metal case of your kettle or toaster. Its entire job is to be a safety escape hatch. If something goes wrong inside, say a live wire breaks and touches the metal casing, all that dangerous current suddenly has a choice to make.
And here is the beautifully simple physics of it all. See, electricity is, for lack of a better word, lazy. It will always take the path of least resistance. And that earth wire is specifically designed to be a super easy, super low resistance path to the ground. Way lower resistance than, say, your body.
So, if there's a fault, that huge surge of current doesn't even think about going through you. It sees that easy path, the earth wire, and rushes down it, harmlessly going right into the ground. It's such a simple, elegant idea. That one extra wire makes sure the metal casing can never become live, and it's what keeps you safe from what could be a really nasty shock.
So, the next time you flick on your kettle, you'll know that a simple wire, working because of the fundamental laws of electromagnetism, is basically your personal bodyguard. And it really makes you wonder, doesn't it? What other invisible forces are out there, hiding in plain sight, quietly shaping our world and keeping everything running smoothly every single day?